Hello guys, welcome back to the channel Mathemagix JEE. This is the question number 9 of this sample paper. It is saying let the functions f and g be defined by fx equal to this 3x plus 4 cos x, okay, and gx is this, okay. Let f of gx, this is the composite function fg, so it is defined from open 0 to 2 to r, okay. Be the composite function defined by f of g of x is this, okay. Suppose m is the number of points of local maxima of f of g in the interval open 0 to 2, and suppose n is the number of points of local minima of f of g in the interval open 0 to 2, okay. Then the value of 2m plus 3n is what, okay. So let us calculate first the composite function, okay. H of x, let's say this h of x is f of gx. So f of gx will be simply 3 into 6 pi x minus 1 whole square, that means 18 pi times x minus 1 whole square plus 4 cos, it will be 6 pi x minus 1 whole square, right? So we have to differentiate this function to check for its critical points, right? So h dash x will be, simply if we differentiate this, 36 pi times x minus 1 plus it will be minus 4 sine this, and then it will be 12 pi then x minus 1, right? So we can write this as, if we take this 12 pi into x minus 1 as common, we get 12 pi into x minus 1, then it will be 3 minus 4 sine 6 pi x minus 1 whole square, okay. So like this. Now we know exactly the critical points. One critical point will be x equal to 1, right? And other critical points will be here from this factor. So we can say critical points will be sine of 6 pi x minus 1 whole square is equal to 3 by 4. Okay. So uh, how many factors will be there? How many critical points will be there? So we can analyze by this domain, okay. So this domain indicates our x here belongs to the open interval 0 to 2, right? So x minus 1 should belong to the open interval minus 1 to 1, right? So we can say x minus 1 whole square will belong to the interval closed 0 to open 1, right? So this thing here inside this sine function will vary from 0 to 6 pi, where this 0 is closed and 6 pi is open, right? So we have to consider uh, all the solutions that occur in close 0 to 6 pi for this equation. So let us plot this graph of sine, right? So sine is like this. Now sine function is periodic with period 2 pi, right? So we can analyze this situation for 0 to 2 pi only, and then we can multiply by 3 to get the total number of solutions. So here we can say this will be, let's say, the line y equal to 3 by 4. Okay. So in 0 to 2 pi, there are two solutions of this equation. Sine of this some t equal to 3 by 4 gives us t equal to this and t equal to this. Okay. So now how many critical points will be there? There will be total 6 into 2, 12 critical points, right? Because for each of these points here, we have two values of x, because this is a quadratic term, x minus 1 whole square. So we can say by the graph of x minus 1 whole square that any line here will cut this graph two times, right? So there will be two solutions corresponding to each point. So we have total 12 critical points from this factor, and then this we have as a separate critical point, right? So we have to check the nature of these functions at this points, whether it is a maxima or minima, right? So let us check this. So we calculate h double dash x, okay, to check for maxima or minima. We apply double derivative test. So h double dash x will be, if we differentiate 36 pi, this will be minus, then 48 pi we can take as common, so 48 pi, then x minus 1 times cos of this factor here, 6 pi into x minus 1 whole square, 6 pi into x minus 1 whole square times the derivative of this will be 12 pi into x minus 1, then it will be plus, uh, it will be sine of this, right? Now the derivative of this will be 1. So if we simplify this, we get 36 pi minus 48 pi, this will be x minus 1 whole square, and it will be 12 pi again, so pi square into this we can write as 12 into 48, so 12 into 48 as it is, let us keep this, okay. And then we have cos of this 6 pi x minus 1 whole square, then we have plus 48 pi sine 6 pi x minus 1 whole square. So we can say, if we check this behavior of this double derivative at this point, so let's check this first at x equal to 1, okay. So h double dash 1 will be how much? This factor will be 0, this factor will be 0, so 36 pi, that means greater than 0. That means we can say x equal to 1 is a point of local minima. So then if we check for other points here, so if we check for these points, right, so let us denote these points by x equal to alpha, okay. So alpha may be variable, but let us denote all these points by a single variable alpha. So if we check here, we get h double dash alpha, let's say if we check, we get it is 36 pi minus, this is as it is, pi square into alpha minus 1 whole square cos of 6 pi into alpha minus 1 whole square plus, now this thing we can write as this sine of 6 pi into alpha minus 1 whole square we can write as 3 by 4, right? So 3 by 4 times 48 pi, this will be 1, right? So this we can further simplify. I think here it will be minus, right? So minus, and here also minus. So then we have here 12 and here 36 pi will get cancelled, okay. And then we have this minus 12 into 48 pi square, then alpha minus 1 whole square cos of 6 pi into alpha minus 1 whole square. So we can see a very interesting thing here, that the sign of our double derivative depends on this cosine function, okay. So this factor is positive, right? This factor is always positive, and here it is negative sign. That means if our cosine value is positive, our h double dash alpha will be negative, right? And if cosine value is negative, h double dash alpha will be positive. So it all depends on this cosine factor. So let us plot these solutions first, okay. So as we discussed, as this cosine function is periodic here, with period 2 pi, we can analyze this situation for 0 to 2 pi only, and then multiply by 3 to get the total number of solutions for 0 to 6 pi. But again, we have to also consider that double factors, right? Because alpha minus 1 whole square will give us two distinct values of alpha. That means here if we draw the graph of cosine function from 0 to 2 pi, here it is 2 pi, this is 0, and also simultaneously draw the sine function, okay. So like this, okay. So now this is the line y equal to 3 by 4, okay. So we have already two solutions here, this and this. Now think about this, if we consider only this cosine graph, so y equal to cos of this argument So we can say that corresponding to this point our cosine value is positive, right, this point, and corresponding to this point we have our cosine value as negative, right? So we can say, let's say this point is some alpha I, then this point is our beta I. Okay, so we can say cos of alpha I is positive, which means this h double dash alpha will be negative. That means we have points of local maxima. And also when cos of beta I, this cos of beta I is negative, right? So we have points of local minima. That means how many points we can get from this? This point will correspond to 3 into 2, that means total 6 points, right? So we have total 6 points here, and corresponding to this point we have total 6 points here. That means we have local maxima here at 6 points and local minima at another 6 points. But there was already a point of local minima here, which is x equal to 1. That means our total number of minima points will be how much? It will be 7, right? And total number of maxima points will be 6. So from these two informations we can say the number of points of local maxima is m. Okay, so this is m and this is n. So m plus, sorry, 2m plus 3n will be our the required value, right? So it will be 12 plus this will be 21. That means 33. So the correct answer for this question will be 33. Okay. So this was altogether a very good question on maxima and minima.